class. Welcome back. We are going to do a little unit on reason and argument. Consider this a mini logic lesson. This handout is pretty much the outline for the entire logic class. So we're getting a little brief logic overview. And we've talked about this before. We talked about the formative use of reason. Reason is used to form concepts, judgments, and arguments, the forms of all thought. So now we're going to go into more depth into those forms of thought. I will remind you about some of these. It's a review for us, but we'll get into some things that are not review. By reason is meant the laws of thought or logic. The law of identity, A is A. The law of excluded middle is either A or non-A. And the law of non-contradiction, not both A and non-A. These laws are natural laws. Remember, they are part of human nature to use them. We've also talked about this. Reason is used as a test for meaning, the critical use of reason. Reason is used as a test for meaning primarily and as a test for truth only secondarily. If a law of thought is violated, then there is no meaning, and wherever there is meaning, reason is being used. Okay, that's review for us from the reason handout. Also review, reason is used to form concepts, judgments, or propositions, and inferences or arguments. Now, this is a little bit new maybe. I think I did talk about this when we went over the reason handout, but now we have a little more depth. In a concept, the mind apprehends the essential nature of a thing. So we're grasping what a thing is. A concept is expressed by a word or term. Okay, so a concept is the idea in the mind. It's expressed by a word or a term when we communicate. A definition expresses the meaning of a word or the concept expressed in the word. So we define the things. We define what a being is with words. A definition expresses the meaning of a word or the concept expressed in the word. The essence of a class of things is the set of qualities that all members and only members always have. So think of a class of things like dogs. Dogs are a class of beings that all members and only members have a set of qualities in common. That's the essence of the thing. Word, definition, meaning, concept, and essence are closely related. In all of the above, A is distinguished from non-A by reason, the law of identity. Concepts are logically ordered from most basic to less basic concepts. This is presuppositional thinking. Remember, we have more basic and then less basic. And we gave the example, meaning is more basic than truth. Well, concepts are more basic than judgments, and judgments are more basic than arguments. So the handout is also logically ordered. So here's a summary about concepts. We're going to move on now and talk about judgments, and this is where we're going to need to take notes. You're going to learn new things about the square of opposition, and I want you to memorize some things for your long-term memory, and I'll tell you what. A core question from the handout. In a simple judgment, two concepts are joined by affirmation or separated by negation, is or is not. In a compound judgment, two propositions are joined by or, if then, and. So we'll talk about that later. Right now we're going to talk about simple judgments. Simple judgments are either true or false and are expressed by propositions. And we're going to talk about categorical propositions. Categorical statements, they use all, some, or none. We've talked about this before. The four forms of propositions differ by quantity, all or some, that's how many, and quality, is or is not, affirming or negating. So these are the four propositions, and I'm going to show you those propositions drawn on the square of opposition. Remember, I told you we would come back to the square of opposition and I would teach you about them. Now I'm going to do that. So let me get the iPad out And we're going to draw the square of opposition on the iPad. And I'm going to show you how these judgments are related on the square. This corner is the A corner. This is E, this is I, and this is O. This is called the square of opposition. Now, A, E, I, and O represent the kind of proposition that goes there in that corner. So A statements are universal and affirmative. Universal means all of them, every single one of them. Affirmative means is. So whenever you make an all is statement, it's an A statement, and we're just going to put S and P as placeholders for a subject term and a predicate term, where a subject term is any concept. All iPhones are Apple. Okay? Actually, I have a better example we'll use. So all S is P. That's an A statement. Okay, that's the universal affirmative. The E statement is related by being its contrary. The contrary statement says no S. Actually, let me go back. Let me go back and tell you it's a universal negative statement. And the universal's none. Absolutely none. And negative is none. So no S is P. That would be saying no iPhone is Apple. We would say that's not true, right? Now, the relationship I pointed out last time, the one I really want you to know about is the contradiction. And that's these diagonals. I'll say CTD as an abbreviation for contradiction. If I said no iPhone is Apple made, what would you do to show me that's a mistake? You would show me some, right? You'd say, no, some of them are. Here's one. Apple made this iPhone. So that would be the I statement, which is a particular, at least one, a particular affirmative statement. At least one iPhone is made by Apple. I have it right here on my table, right? So we'll say some S is P. That's the particular affirmative. Now you can guess what the O is, right? What's the only one that's missing now? This is the particular negative, which is what? I'm going around saying all iPhones are made by Apple. The contradiction to that would be some iPhones are not made by Apple. But that wouldn't be true, right? Some S is not P, where S and P stand for subject and predicate terms, concepts. Put them in there. Okay, I would like you to know this square of opposition, know what it looks like, know what A, E, I, and O statements look like. I'm going to go back to the handout for a moment, and we're going to, that's not what I'm looking for. I got a lot of editing to do here. Here we go. Okay. So I showed you all S is P. Okay, in a simple judgment, we have the four. All S is P, universal affirmative, the A. No S is P, universal negative, the E. Some S is P, particular affirmative, the I. And some S is not P, particular negative, the O statement. And now it says the four propositions are related in the square of opposition by contradiction. A and O, E and I showed you that, but I'll review it. And contradictions differ in quantity and quality. Both cannot be true, both cannot be false. I want you to be able to answer this question as a core question. Define contradiction in 3 ways. It's right here, and I'll give you the third way. Contradictions differ in quantity and quality. Quantity is how much? All versus some. No versus some. And quality is difference in affirmative or negation. All is, some is not. No is, some is. Both can't be true and both can't be false. That's the second way. The third way is I want you to give me an example of a contradiction. So let's go back to the square, and I'm going to show you what I'm looking for in an example. So here's differs in quantity and quality. Let's just highlight that. Universal, particular. Affirmative, negative. Okay, that's differ in quantity and quality. That's for the contradictions. Now let's go over here. Universal, particular. Negative, affirmative. That's how you know a contradiction. They differ in quantity and quality. And both can't be true and both can't be false in the same respect and at the same time. Now I'm going to erase this board and give you a new example. I'm going to give you my example. You have to give me your own example. You can't use mine. So here's the new square of opposition. And I'm going to make some crazy claim. All apples are red. All right? I come to you and I say, all apples are red. How are you going to show me I'm wrong? What's the contradiction? What would be the contradiction? It's not no apples are red. That's a contrary. And people in philosophy often, people everywhere, often argue contraries, all or nothing, and those could both be wrong. All apples are red is contradicted by, think of universal, this has to be a particular, right? And this is affirming, so it has to be negating. So what's the particular negative? It is some apples are not red. You can bring me a yellow apple, a green apple, and say, look, Dr. Burton, all apples are not red. Some apples are not red. Those are the same, by the way. If you take logic, you find that out. All right, so let's look at the other contradiction here. That would be this corner, these two corners. What's the contrary of all apples are red? I just told it to you. No apples are red, right? What's the contradiction of no apples are red? It has to be a particular affirmative. Some apples are red. So I want you to give an example of a contradiction. Now, students sometimes just draw out the whole square. That's not what I'm asking when I ask for a contradiction. I'm asking for either these two corners, that's a contradiction, or these two corners, that's a contradiction. So I want you to fill in the blanks, S and P, and give me your example. Okay, so that's the core question from this handout right here. Define contradiction in 3 ways. They differ in quantity and quality. Both can't be true, both can't be false. Give me your example. Don't use my apples. Don't use bananas either. Be creative. All pickup trucks are Fords. Some pickup trucks are not Fords. Now you can't use that one either. Okay, let's move on and talk about the other corners. Contraries, which are the A and the E at the top, they may both be false, both cannot be true. So all apples are red, no apples are red, those are both false, right? So contraries can both be false. Subcontraries, I feel like I should draw this again. Subcontraries, we haven't talked about those yet. I'm going to write all S is P, no S is P, some S is P, some S is not P. You know the relationships already of contradiction. So let's say CTD, that's contradiction. You know contraries. And the rule for the contraries, the top one, both can't be true, both can be false, okay? So you can have a false and a false here. Okay. Subcontraries are down here. The rule for subcontraries. Let's go back to the handout. The rule for subcontraries, I and O. They may both be true, both cannot be false. So you can have two trues on the bottom, or you have one true and a false, but you can't have two falses on the bottom. Subalterns, which is A and I and E and O. If the universal is true, the particular is true, but not the reverse. So let's draw that. Let me show you what that means. If A is true, then I is true. If the universal is true, then the particular is true. So if all iPhones are Apple, then some iPhones are Apple too, because some is included in all. But you can't go, some iPhones are Apple, therefore all iPhones are Apple. That would be a mistake. You can read down the square, because all includes some, but you cannot read up the square. That's a logical error to go from some to all. Some human beings are nice, therefore all human beings are nice. No. Okay, the same is true here. No S is P includes some S is not P. No onions are tasty, so some onions are not tasty. This onion I have in my kitchen, not tasty. But you can't go, no, some onions are not tasty, therefore all onions are not tasty. That would be a mistake, right? Some people are not nice, therefore no people are nice. No, that's not true either. Some people are nice and some people are not nice. And we got to learn to be discerning on that stuff, right? Okay, so these are called subalterns. I can't fit it all, so I'm just going to say subalt. So now we have all the relationships on the square. The diagonals are contradictions, the top one's contraries, the bottom one's subcontraries, the sides subalternate, and now you also have the rules for using the square on this handout. Subalternates, if the universal is true, the particular is true, but not the reverse. Now, I don't need you to know all these rules right now. I do want you to know contradictions defined in 3 ways. The meaning of a proposition is made clear by analyzing its concepts and its form. To oppose a position, the contradictory of the position must be established. So what we're going to do is use that square of opposition in metaphysics, which I will reserve for the next handout. I want to conclude this handout by going back to our discussion we started already on argument. So let's talk about argument. We were talking about argument on the knowledge handout last time. So let's go through this. The following apply to deductive arguments only. Inductive arguments are treated later. That's for the logic class. Inductive arguments are based on our observation. Deductive is purely reasoning. An argument uses premises. Okay, pause. I want you to know the definition of an argument. Here's another core question from this handout. Define argument, validity, and soundness. So an argument is valid, that's validity, and soundness. That's a core question. You should know this as an educated person. Define argument, validity, soundness. So here's an argument. An argument uses premises, reasons, their judgments, to support a conclusion, the point being proven. So we tend to think an argument is something we don't like, it's uncomfortable, it's people bickering. No, in philosophy, an argument has a particular meaning. It's a structure, premise, conclusion. An argument is valid if the premises logically support the conclusion. And that means it's in good form and you can test the form of an argument. That's what the discipline of logic is all about. Lastly, an argument is sound if it is valid, it's in good form, and the premises are true, which is needed for rational belief. So in the handout on the definition of knowledge, we said knowledge is justified true belief, and justification is by reason and argument such that the opposite is impossible. We're going to combine these two methods to get arguments for metaphysics. The following argument or syllogism forms are commonly used. In the categorical syllogism, two concepts related to a third are related to each other. Here's an example of an argument. We've done this one before. All S is M, all M is P, therefore all S is P. All men are mortal, Socrates is a man, therefore Socrates is mortal. Okay, so these other arguments we'll leave off for right now. Hypothetical syllogism, we will, you know what, I'm going to leave those off because I'll show you those when we do them so that you don't have to be bogged down, and we're getting a little long on this video. So I want you to know contradictions. Define contradictions in 3 ways. Remember, you're going to give an example. Define argument, validity, and soundness. And that's what I want you to know from this handout as part of the core questions. This handout is a transition from what is knowledge to how can we get knowledge. Now we're going to transition to what can we know, and it's going to be exciting. So I hope that you take good notes, prepare for the quiz, and I will see you in the next video. Thank you for joining me.